Go. Number 27. Number 27. They want us to divide this polynomial by this binomial. Back when we learned how to divide polynomials, I taught you a method called synthetic division. Okay, you're going to make like a little box, not really, but half a box. What number will go in that box? 6. You always look at what it's being divided by. Since it's x minus 6, you put a positive 6 in there. Then you look at the polynomial and you list its coefficients and then its constant of 42. Okay, then you draw a line. The first number, no matter what it is, always comes down. Whatever drops below the line gets multiplied by the number in the box. 1 times 6 is 6. From there, you just combine. This is a negative 9, that's a positive 6, so that becomes a negative 3. Because negative 9 plus 6 is negative 3. Now that that dropped below the line, you multiply it by 6, and that gives you negative 18. That becomes a negative 7. You multiply it by the box number and get a negative 42, which leaves you a remainder of 0. Now, one thing to remember is that the question started out as degree 3. It started out with x cubed. Your answer always starts out one lower, x squared. So x squared minus 3x minus 7, remainder of 0, which is 8. Okay. You divide, we're dividing by x minus 6. So positive 6 goes in the box. Then you use this polynomial's coefficients of 1, negative 9, 11, and then the constant of 42, and write them there. The first number always drops straight down. That's how 1 got there. It then multiplies by the box number. 1 times 6 is 6. Negative 9 plus 6 is negative 3. It then multiplies by 6 to make negative 18. 11 minus 18 is negative 7. It then multiplies by 6 to make negative 42, which gives us 0. Yes. Whatever drops below the line multiplies by 6 to give you that next number above the line. Like what if this was x plus 6 to begin with? Then it would be negative 6, and every number would have been multiplied by negative 6. Okay, I'm going to give you a minute to try 29 by yourself. It's the exact same type of problem, it's just written differently. Instead of writing it like this, they write over for divided by. So let's go ahead and look at it. Okay, what goes in the box? Positive 10, because it's divided by r minus 10. What numbers go here? Okay. Then we always start by bringing down the first number. Then it multiplies by the box number and makes 10. Negative 12 plus 10 is negative 2. Negative 2 times 10 is negative 20. 23 minus 20 is 3. 3 times 10 is 30, which this time gives you a remainder of 8. Okay, since it started out cubed, our answer starts out squared. And then you just go down from there, which is D. This is just another way that they write the remainder sometimes. Well, or add them. Negative 12 plus 10 is negative 2. 23 plus negative 20 is 30. You just do what the sign says. That's technically a positive 10, so negative 12 plus 10. Okay. Okay, what number are we on? 31? What is the degree of f of x? Okay, what's the degree of that polynomial? A, 7. 2 plus 2 plus 3 is 7. Let me show you a scenario where you don't find the degree like that. If you have f of x equals 2x squared minus 5x cubed plus 5x minus 3. What's the degree of that one? 3. Okay, you look for the highest the highest exponent when it's written in that kind of form. When it's written in factored form, which is this, you add them up. When it's not written in factored form, you just find the largest exponent. Now, let me try to explain why. If I took x squared, x plus 5 squared, hold on, let me get to a different page. X squared, x plus 5 squared, and then the last one was x minus 3 cubed, right? Or was it? X minus 3 cubed, yes. Oh, okay. If I wrote out x plus 5 squared, wouldn't it look like this? And if I wrote out x minus 3 cubed, wouldn't it look like this? Okay, well, just sit tight for a second. I'm going to first start by foiling these two. X times x is x squared. X times 5 is 5x. Another 5 times x is another 5x, and 5 times 5 is 25. That set of binomials then simplifies to x squared plus 10x plus 25. Okay, so I'm done with those two. It became this trinomial. I'm going to FOIL these two. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is another negative 3x. And negative 3 times negative 3 is positive 9. That then becomes x squared minus 6x plus 9 when you combine them. But I still have all of this left. Okay, if I even started, say the next thing I do is I distribute out this x squared to all of this. That becomes x to the 4th plus 10x cubed plus 25x squared. Then say I distribute this binomial to all of that. X times x squared is x cubed. X times negative 6x is negative 6x squared. X times 9 is 9x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 6x is positive 18x. And negative 3 times 9 is negative 27. And then I go and start distributing all of that times this. What's x cubed times x to the 4th going to make? X to the 7th. Which is why it's a degree 7. Because eventually if I know, but you get why it came out as degree 7? Because if you literally multiplied all of those out, it would come up with x to the 7th power. Now over here, this is already multiplied out, and the highest one ended up being a 3, so it's degree 3. But here, we have to add them up to know what it'll end up being when you multiply everything out. Does that make sense? Kinda? Okay, number 33. Which of the following represents the zeros of f of x and their corresponding multiplicity? Okay, well, when somebody tells you x plus 5, where does that actually cross the x-axis? Negative 5. Okay, and since it's squared, doesn't that mean it's a multiplicity of 2? It's going to bounce at negative 5. X minus 3 means it actually crosses at positive 3, and it's cubed, multiplicity of 3, which means it's going to flatten out there. Okay, so we know we're looking for a negative 5 and a positive 3. That's wrong. That's wrong. Now we have to decide if there's not a 0 or if there is. Where would it cross the x-axis for x? 0. Think about it. If you graph y equals x squared, doesn't it cross at 0? And it doesn't just cross, it bounces. And why does it bounce? Because it's squared. So there's also a 0 at 0, and it's a multiplicity of 2, which is table 4. Number 35. Which of the following represents the interval of decrease for the function shown below? Okay, well, how many times is it decreasing? 2. 1, 2. Now, that right away tells us that it's not C because it's in 2 places. It also tells us it's not D. All real numbers would mean it's decreasing everywhere. It's obvious that it's not decreasing everywhere. It's increasing right here. Okay, now what is very important about intervals of increase and decrease is that you only look at the x-axis. So we do not care about any y values. You're not even going to pay attention to the y values. You're only going to pay attention to the x values. So when did it start decreasing? Negative infinity, right? This means that it started decreasing way back here somewhere. So negative infinity, which both of them start out like that. When did it quit decreasing? Negative 2. When did it begin decreasing again? 0, and then it increased forever, so it's B. Does that make sense? Okay, next page.
How many we did?
To 51.
To 51.
Today?
I thought it was
Yeah.
37.
All right, number 37. Which graph below represents a polynomial function that has the following characteristics? Okay, well, we can see that it has 3 zeros, which are 3 x-intercepts. So it definitely cannot be B, and it cannot be C. Each of those only have 2 x-intercepts. We're looking for a graph that crosses at 0, 0. This one does. Negative 3, 0. This one does. And positive 3, 0. This one does. However, so does D. The only difference is their direction. So we have to look at the end behavior. Okay. X-axis runs what directions? Left and right. So x approaches positive infinity would be which direction? Right. So x approaches negative infinity would be left. Okay. F of x is the same thing as y. Y approaches infinity would be what direction? Up. Y approaches negative infinity would be down. So they want you to pick the graph that as it goes right, it also goes up, and as it goes left, it goes down. D does that. See, right side up, left side down. Okay, next page. Number 39. Use the polynomial function below. Which of the following are appropriate characteristics of the function? The first thing you should do to start this is graph this polynomial function. Okay, so y equals 2x to the 8th power minus 3x to the 5th power. Oops. Plus x. Okay, when we graph it, this is what it looks like. Okay, let's look at our choices. Has a local min, has an absolute max. Has a local min, has an absolute max. We can narrow it down to 50-50 just by knowing which one of those is correct. Does that have a minimum or a maximum? A minimum. Okay, obviously this is the lowest point. It goes up forever, so does it have any kind of maximum? No, so we can rule out B and C. Now, let me show you what they're talking about when they say local min. I'm going to zoom into the calculator a second. Zoom in, and then you have to hit enter for it to actually happen. How many minimums does that graph have? 2. This one, which is the lower of the 2, right? That is the absolute max, because that's absolutely the lowest it'll ever go. This is the, min, my bad. This is the local minimum. Okay? So absolute minimum, local minimum. But there is no max at all, because it goes up forever. Zoom in, which is number 2, and then you have to hit enter to actually do it. And see, mine zoomed in even more. So I'm going to go back to, if you want to get back to the standard graph, you do zoom standard, which is number 6. Okay, now we need to decide, is the domain all real numbers, or is the domain from -1 to +1? All real numbers. Because right now it kind of looks like it's between -1 and +1. But does it mean that it's going to go straight up forever? As it goes up, isn't it slightly going left and right? So that's all real numbers. Okay, we're going to save 41 for last. 43. Given one of the roots of the function is 1, find the other roots. Okay, the first thing you need to do is graph it, because the roots are the x-intercepts. So with a picture, it's very easy to tell where the x-intercepts are. So go ahead and graph it. Yeah, 43. Okay, now we see that it has three roots, three x-intercepts. One of them's at positive 1, which is the one they already listed for us. Where are the other two? 2 and negative 4, which is B. Now, sometimes students get confused and they might put C, the opposite. But think about it. Didn't they tell us the first one was at positive 1? Doesn't it cross at positive 1? So there's no switching signs on those kind. Oh, we're going back to it. Okay, number 45. The graph of the function has zeros at. Okay, well, how many zeros does it have? Zeros is just another word for roots. 3, or x-intercepts. So A and C are out. B and D are very similar. They're just all reversed. Which one is it? B. 0, negative 6 would be here. 0, negative 3 would be here, and 0, 1 would be here, actually. No, only if you're writing them as factors. Like if you're asked to write this negative 6 as a factor, you would write x plus 6. And you would have written, where is that one, negative 3? You would have written x plus 3, and you would have written x minus 1. But you're not writing them in factor form. You're just actually given the points, which are negative 6, 0, negative 3, 0, and 1, 0. So B. Okay, 47. Use the information provided to write the standard form equation of each circle. Okay, well, the center is negative 10, negative 5, so that's your H and K. Just by knowing that, what can you rule out? Right, they're like obviously wrong. Now, A and D are almost identical with the exception of what they're equal to. If the radius is 2, what should it be equal to? 4. You always square the radius. Because the equation is x minus h squared plus y minus k squared equals r squared. You always square the radius, and that's how they got that 4 in the equation. Okay, number 49. What is the standard form equation of each hyperbola? Okay, well, I'm going to write this down because this one requires a little bit of work. Okay, do you notice how the original equation equals 64, but then all of a sudden the answers equal 1? How can you turn a 64 into a 1? Divide it by 64, and then that'll become a 1, correct? However, you can't just divide one side by 64. You have to do both sides, and I'm going to do it under both binomials. Okay, so that lets me know right away that y plus 10 squared should be over a 64. So that one's out. This is x minus 5, so this one's out. There's no x plus 5. Why is A out? Yeah, they flip-flop. Okay, so where did the 16 come from under the x on both of them? The 4 over 64 reduces to 1 over 16. Cancel out the what? Because it has x plus 5 and it's supposed to be minus 5. Okay, so notice how the 64 stayed under the y's on both of them, but now all of a sudden under the x's is 16. That's because this 4 over 64 reduces to 1 over 16. So now you should have a 16 under x minus 5, which both of these do. So which order is correct? B's already eliminated. C. The main thing you need to look for is the sign. See how the minus is with the one with the 16? The minus is the one with the 16. Make sure you match those up. Okay? Yeah, that's down here. Okay, number 51. Use the information provided to write the standard form of each ellipse. Okay, well, where's ellipse? Where's the center of this ellipse? Well, no, just at 1, right? Okay, so how do you represent right 1 when you write it as a factor? X minus 1. So that rules out D. Now, do you have to go up or down on the y-axis to get to the center? No, you just have to go right 1. So that rules out C. You don't have to move 2 units to get to the center on the y-axis. Okay, now you have to decide, should there be a 9 under the x or a 49 under the x? Okay, well look, from the center, which side is the shorter one, the x or the y? So shouldn't the 9, the smaller of the two numbers, be under the x? And the reason it's 9 is because look, 1, 2, 3 squared is 9. On the y-axis, 1, 2, 3, 4, 5, 6, 7 squared is 49. Well, let's go back to 41. We skipped it. We skipped it because it's the most time consuming. I think so. A? Yeah. Okay, 41. Here we go. Last question. The first thing that you need to do is graph this. Okay, so in the calculator, go and graph it. X cubed minus x squared minus 4x plus 24. Okay, since it's cubed, we would have expected it to cross the x-axis 3 times. However, we only see it cross once. Well, that kind of makes sense because look at these solutions. These other two solutions are imaginary. We don't see them. Where's the one real solution? -3, which rules out B and C. Okay, so you could at least narrow it down by finding the one real solution. Okay, now the process of finding the two imaginary solutions is synthetic division to start. You put -3 in the box, and then you take the numbers from that polynomial, 1, -1, -4, 24, and you do synthetic division. Okay, the 1 drops down, multiplies by the -3. That then combines to be a -4. It multiplies by the -3 to be +12. That then combines to be what? 8. It multiplies by the -3 to be -24. So the remainder is 0. You're left with 1x squared minus 4x plus 8. Anytime we see a trinomial, we normally think, oh, well, let's factor using the bubble method. But can you think of two numbers that multiply to 8 and add to -4? No, there are no two numbers that do that. So you have to go to quadratic formula.
Oh my God.
Okay, I'm going to go quickly because we got to finish. Look, the B is -4. A, B, C. If you plug in a -4 beside a negative, it becomes positive. When you plug in a B of -4 and square it becomes a 16, guys, -4 squared, minus 4 times A, which is 1, times C, which is 8. All over 2 times A. What is A? 1. So 2 times 1 is 2. What is 16 minus 4 times 1 times 8? Quickly type it in. -16. Because in 4 times 1 times 8, 32. So 16 minus 32 is -16. What is the square root of a -16? 4i. You put each one of them over the 2. 4 divided by 2 is 2. 4i divided by 2 is 2i. So we're looking for 2 plus 2i, 2 minus 2i, which is A. Tomorrow we'll finish up the odds. I would go home and watch this video. Okay, if you don't know how to do this stuff, you need to watch the video.